Hello and welcome to York Universe, the astronomy and astrophysics radio podcast written and presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. And yes, that does include both Amazon and Spotify. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by Parisa Nozari. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT, if that's more your speed. We are broadcasting live on YouTube at York U Observatory in concert with our online public viewing program run by our amazing observatory team. So if you'd like to see any of the visuals that come along with this show, make sure to wander on over to the YouTube channel anytime you like. To navigate to the live show, to find out more about the archival episodes or live tours at the observatory, or any of our fabulous activities, you can check out our website, yorku.ca/science/observatory. To navigate over to York Universe, you can follow any of the YouTube links on there or search for OPV, which is online public viewing. If you have questions or comments about past shows or suggestions for future topics, you can always email us at observe@yorku.ca. We're also on the social medias, as they say. We're on Instagram with York U Observatory, Facebook at Allan I Carswell Obs, and PixelFed at Allan I Carswell Observatory. All of our programs are free, including this one, but if you'd like to make a donation to that same website before, yorku.ca/science/observatory. Our crew is, of course, monitoring the YouTube chat room for questions if you're joining live and looking at posting content. The current weather is surprisingly good in Toronto, so I'm very, very hopeful that we'll be able to open the 1 meter telescope over on the YouTube channel tonight. How's the weather where you are, Parisa?
Hi, Alina. It was great, beautiful day today. It was very
Yes,
warm. It was like sunny. Everything was like absolutely wonderful.
it felt like summertime, didn't it?
Yeah, and it was such a like great time to like set and like eventually going above zero. And I'm like, yes, good
Yes,
time.
finally in Toronto. The snow mountains have started to melt, and if we're very lucky, we'll be able to get some clear skies. So keep an eye on that YouTube channel tonight, and if it is possible, our crew are standing by at this moment inside the 1 meter telescope to look at sharing some views. And of course, one of the amazing things we can see when the sky is clear, I actually noticed this evening before the sun went down, even, I could see a lovely moon out there. And the moon, very, very easy to spot, even in the daytime. It's very, very bright. We have a moon of about 90% full. And right now, if you're looking up as I say these words live, the moon is nice and high above the eastern horizon. It's about 50 to 60 degrees above the horizon. So if 90 degrees is straight overhead, it's almost there. If you do go straight overhead from where the moon is in Ontario, you'll find the red planet Mars. And when it's clear, it's a absolute gem to view. Mars is going to be that very bright red star looking thing that doesn't quite twinkle. And that's how you can usually spot the planets, is they're not as twinkly as the stars. Jupiter is up as well this evening. So you do have a wonderful show directly overhead this evening in Toronto. And the moon, Mars, and Jupiter are all things that you can see pretty much naked eye if you have anywhere near clear skies. So maybe not in the brightest parts of downtown, but pretty much everywhere else, you'll get a good show. One of the things you won't be able to see without some serious assistance, either telescope or otherwise, is of course the dimmer planets like Uranus and Neptune. And I think, Parisa, that actually gets us to your first This Week in History object.
Yeah, today I'm going to talk about a very beautiful planet like Uranus. and talking about its discovery exactly this week, but back in 18th century. And yeah, so by the time that like Saturn was thought that it actually is the last planet in our solar system, in March 13, 1781, a British astronomer called William Herschel, that it's very well known to all the astronomers right now, used a homemade telescope, spotted a celestial object that didn't quite behave like a star. And at first, Herschel kind of thought that it had discovered a new comet, but then he continued to track its motion across the sky, and then he realized this object wasn't following the usual trajectory of a comet. So then it was something much larger and further away. And so a few months after, like basically months after observation, it just became clear that this was a planet, not a comet. And that was very cool because this was the first to be discovered with a telescope. And why it was such a groundbreaking moment, because Uranus was the first planet to be added to our known solar system since ancient time. And that wasn't visible to the naked eye, like Mercury, Venus, Mars, Jupiter, and Saturn, that it has been observed for thousands of years. But Herschel initially wanted to name it, I think, Georgium Sidus, something like that, or George Star after like King George III. And thank God that he didn't do that. But then the astronomical community at that time eventually settled on Uranus. That was a name like after the Greek god of the sky, and following the mythological naming tradition of our planets. And then we also knew, like, get to know that the Uranus also has rings, but 200 years after that, exactly on today, March 10th, but in 1977. And at this time, astronomer had already sent spacecraft to study the planets up close, but then their knowledge of Uranus was quite limited still. And suddenly something very cool happened because James Elliott, Ted Donham, and Jessica Meng, they were all astronomers that were using Kuiper Airborne Observatory, I think. And that was a telescope mounted on the aircraft flying above Earth atmosphere to study Uranus as it passes in front of the distant star. It's actually very, related to our theme tonight that we're talking about eclipse. That is kind of like a cosmic eclipse, basically this technique called a stellar occultation. And what happens is that as Uranus moved in front of the star, because all these objects like planet and star are point sources, like are very point-like object, so the light from the star should have disappeared all at once. So basically, Uranus eclipsed the star behind it. But then something very cool happened because when they looking at the this observation, before and after Uranus blocked that star, it's the starlight flickered several times. And it actually meant that something thin and dense was surrounding the planet and momentarily blocking the starlight. And then the conclusion was the Uranus also has a system of rings. And at that time, only Saturn was known to have rings. So that was a very cool and huge discovery because these rings are much fainter than Saturn's, and they were all made of dark, narrow bands of ice and rocks. And they were all invisible from Earth without advanced instruments. And that was why it took such a long time for astronomer to detect them. And we later on we also got Voyager 2 flyby in 1986 that confirmed and expanded basically our understanding of these rings, that it revealed that Uranus has at least 13 known rings and likely formed from a remnant of shattered like moons before. But as I said, like what was very cool about it, because we kind of figure out that it's not only Saturn that has rings, but also other like all the gas giant like Jupiter, Saturn, Uranus, and also Neptune have ring systems that they all quite different and vary in size and visibility. Yeah, so I think that was very cool that I kind of find um the ring detection kind of needs some eclipse to happen to for us to understand that there's something surround Uranus to make those flickering lights. Yeah.
Absolutely. And of course, as you say, it really does kind of have the it's two different words for a very similar interaction in astronomy. So an eclipse is when you have sort of the sun and the earth and the moon involved really. So if you're going to have a eclipse, you have things like a total lunar eclipse, which we're going to talk about later in this episode, when this moon goes into Earth's shadow, or you have the solar eclipse where, of course, the moon goes in front of the sun. Um, but if you have an occultation, this is kind of any large thing blocking the smaller things. So in this case, the large planet blocking those smaller stars off in the distance. And so you have things also. The moon can have occultations for the planets as well. Our moon, but it's the same idea as something is blocking something else. So something is blocking the light from coming through. And so an occultation, in this case, watching Uranus uh, move in front of stars, you watch the starlight very carefully. And so you actually analyze not the planet, but the light from the star and look for changes in that starlight. In this case, as you say, flickering. And of course, Uranus is incredibly unexplored compared to our own moon or Mars or um, Venus or Neptune or Jupiter or even Saturn, because Uranus has never had a dedicated orbiting mission. It's only had Voyager 2 just fly by and take pictures. So, and we've never gone back. So there's so many things we still don't know about this planet. It remains a little bit of a mystery, but the best images now have come out of actually James Webb Space Telescope. So if you want to see some very, very high detail on the rings and the moons of Uranus, James Webb Space Telescope uses infrared and near infrared light, which is looking in a different wavelength than humans can see. So it looks towards basically if you ever saw the movie Predator, they use heat vision. That's kind of the infrared direction. So it's looking at sort of a heat vision view of the planet, and the rings and the icy rings really pop out. And so the near infrared images that have come out of the James Webb Space Telescope really clearly show lots of detail on those thin, thin rings that Uranus does have, as well as some extra detail around um, some of its Shakespeareanly named moons. It has moons like Titania and Oberon and Ariel and Miranda. So it does have its own little theme around its moons as well. Very interesting planet, very interesting moons, and I think that might be how I can get us to our next item in his this week in history. Um, Let me go ahead and start off. We have this week a total lunar eclipse. And not just this week, but this week in history as well. So if you have been reading the news, or maybe just if you're anywhere in North America, you might have heard that coming up soon on March 13th, there's going to be a total lunar eclipse. And actually, this will be visible throughout almost all of North America and the entirety of Canada. So everyone in Canada will be able to see it. But this isn't the first time this has happened. Back in the year 1522, on March 12th, there was also a total lunar eclipse. And this is really interesting. Total lunar eclipses are easier to see and document than total solar eclipses because this is when the moon passes into Earth's shadow. And the entire moon will appear red if it's passed into the darkest part of Earth's shadow. Everybody on the nighttime side of Earth, if they're looking up and have clear skies, they can easily see it. And so these lunar eclipses are easier to see, easier to document than the total solar eclipses, where only a tiny, tiny piece of Earth can see them. So we can actually match them quite easily to specific dates and actually to historical events as well. Because we can mathematically calculate eclipses, we can actually use them to put real dates onto historical events that happened near eclipses, which is really fun. With modern modeling and physics, we can go back in history easily and recalculate and calculate what different eclipses were like. And that's actually how we know that in 1522, the March 12th, total lunar eclipse lasted for 29.3 minutes. And we know it was part of the Saros cycle of eclipses 105. And the lunar eclipses of Saros 105 all occur at the moon's descending node, and the moon moves northward with each eclipse in that cycle. And so as your moon goes around Earth, it can basically travel once around Earth every month. And that's how long it takes the moon to go around. Every time it goes around, it can, if it's at just the right angle, go through a node where it is lined up with the Earth and the Sun. So if you're trying to create eclipses, this will mean that you can have eclipses not every month, but every couple months. And for sure, at least a few times every year. Because we can calculate eclipses very well with mathematical processes now, we can actually use eclipse calculators to go way back in history. And there are some small errors, but we can actually give a lot of detail on each and every eclipse in the last couple thousand years or so. How do you do this? Well, um, this is a little bit of fun, but if anyone likes to trace the math, the process currently used by NASA actually uses a theory published by Bretagne and Francois in 1988. So being able to calculate eclipses this accurately is a much more recent process with math, and of course, now we have better computers as well. The moon's coordinates, how we tell where the moon is in the sky, is still based on the theoretical equations from Chaperon-Touze and Chaperon in 1983. So the 1980s were the time when we actually set most of the equations still used for finding out where the moon is. However, to get the most accurate values for the moon position, we need to use the Apollo Lunar Laser Ranging Experiment. That's right, the Apollo missions. We went to the moon and the astronauts left a reflecting array on the moon's surface so that when we on Earth shine a laser onto it, it actually reflects back to us. And we can measure very accurately how long the laser light takes to travel from Earth to the moon to bounce off the reflector and come back. So if anyone ever wondered what's left on the moon, this reflector is one of the most useful things up there. And that lunar laser ranging experiment still gives us revised values for the moon's acceleration and exact position every year. The largest uncertainty in eclipse predictions now is actually caused by fluctuations in Earth's rotation, so things like tidal friction and the increasing height of the oceans. This means that there can be some drift. And of course, we have lots and lots of fun things you can get into if you want to really get into the math, but we won't do that on the radio show. There have been a lot of fun things about it, and if anyone wants to look up some historical eclipses, I'll actually recommend the EclipseWise lunar eclipsewise.com/lunar website, where they have a very long list of total lunar eclipses, total solar eclipses, with some of their fun historical counterparts if they have them. And with that, I think I'll go ahead and wish the old eclipse of 1522 good luck, and of course, thinking very happily about our upcoming eclipse. I will just note that because the weather is so excellent in Toronto, our 1 meter telescope has managed to open. And if you are watching live, or if you want to catch live action views of the lunar surface from the 1 meter at Allan Carswell Observatory, make sure to go check out that YouTube channel because it is showing some really wonderful images. Of course, using a 1 meter is a little bit cheating. We do have the neutral density filter on. Parisa, do you have a favorite area of the moon?
Um, well, I'm very bad with names, but not particularly, but I think I just like love um the most gigantic, like the big part of, like, I don't know, like, I don't know. I don't have any favorite. I think the moon is
No favorites?
beautiful.
No Apollo landing site? Well, I'll go ahead and introduce a favorite for everyone. There is a crater that looks an awful lot like a smiling kitty cat. It is located in Mare Crisium, where the observatory team is currently driving the telescope around. So I recommend everyone to go and see what we're trying to rename as Happy Kitty Cat Crater, and pick your own favorite image of the moon. There's lots and lots of great areas to explore, of course, with the Mara and the highlands and very different types of textured surfaces. It's something that I find I never get tired of watching what the moon does. And
Yeah,
speaking of
exactly.
watching, oh yeah, and Parisa, your article next has a um, wonderful tie-in, because speaking of watching the moon, there's some very strange things that can happen when you start watching the moon. Do you want to talk about your next historical item?
Yeah, absolutely. So, all related to eclipse stuff. There was a solar eclipse that happened on March 9, 1997, that basically millions of people across mostly Asia and Pacific were looking up at this total solar eclipse. But there was something very strange and unexpected seemed to happen. Basically, astronomer recorded very unusual variation in gravity. So, and what does that mean is that if we imagine the gravity kind of like as a piece of fabric, and then we just like putting object, like the heavy job object on that fabric, it kind of just bend this fabric, and that is what we kind of known as a gravity. And just putting a heavy object in the concept of the gravity can make some gravitational wave that we can detect. So, this variation in gravity means that our understanding of this gravity, this fluctuation, basically like a little wave, was varying very unusual during that eclipse. So, and then solar eclipse usually offering us very unique opportunity to study our atmosphere, light behavior, and even gravity. As I just talked briefly that how our like perception of the gravity is. But during this particular eclipse, some astronomers and even like some independent observers reported a minor fluctuation in those gravitational measurements. And this phenomena has been linked to a lot of controversial kind of like, I think, alias effect. That's how they call it, because it was first observed by a physicist called Maurice Alias in the 1950s, where pendulum and gravimeters behave strangely during that eclipse. And that could basically they just rise a question that could the perfect alignment of the sun, moon, and earth somehow be affecting gravity or not? And several gravimeters positioned in different location to record the slight variation during the eclipse and adding fuel to the ongoing debate still, that we couldn't really see that in any other eclipse. And some astronomers suggest that these anomalies were due to atmospheric effects or instrumental sensitivity or even human error. But others, however, argue that there might be an underlying physical process at play and one that challenges our current understanding of gravity, which still very puzzle question that we haven't figured out and people are working on it. But then the 1997 eclipse became another data point, basically, in a series of similar observations from past eclipses. But the question still remains unanswered, that do solar eclipses cause real measurable gravitational effects, or are we simply misinterpreting the data, or while I don't know, or something else is going on to while mainstreaming the physical holds that I don't know, our understanding of gravity is maybe different. But the very particular part of this eclipse that we couldn't really see the same effect in other eclipses. And we the 1997 eclipse stands a fascinating case where we still do not know what's going on. And I think you mentioned that there is a very teeny tiny difference, but that puzzles people a lot.
Yeah, it is very important to note that the fluctuation that they measure is very, 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 very small. So what they're doing in a lot of these experiments with looking at gravimeters, a lot of times the older experiments, they're really just using kinds of weighing scales, and it's a simple weighing scale where you could use something like a spring to counteract the force of gravity pulling on an object. And then the change in the length of the spring can be calibrated to the force required to balance a gravitational pull. So very simple gravimeters might be using things like, weights on springs. And if you can imagine a weight on a spring kind of wobbling about on Earth, a lot of things could make it wobble. You could have a train going by, you could have the building creak, you could have all kinds of things happen where it would just move the teensiest, tiniest 10 to the minus 8 centimeters. So it's a very, very, very small effect that they're seeing. And one of the great questions is it real? And how do we get better measurements? But of course, as I say in physics, if you really want to confuse a physicist, ask them to completely explain gravity. Because gravity is one of those things that's, despite having very good predictions for, we still don't quite understand as physicists, at least not in the way that we wish we did. So perhaps this problem will help future physicists and, of course, give us all a good reason to go out and look at eclipses. Speaking of looking at eclipses, I suppose. Do you have a favorite eclipse, Parisa?
I haven't had a chance to see the solar eclipse, like the total solar eclipse, which happened last year, which was my greatest regret ever. But I think so far I enjoyed watching like lunar eclipse, which I find it very, very beautiful because I think to me just moon turned out to be kind of like a red ball, which I love it so much. But I'm planning to travel to see the total eclipse in Spain 2026.
Oh, wonderful. Yeah, the lunar eclipses are really, really fun. And of course, one of the great advantages of them they are much, much easier to see because they're viewable for a large amount of the area. Of course, the one that's coming up on the 13th, that's only 3 days away from now. If you're listening to this broadcast live, this one's going to be very, very visible throughout most of North America. And getting a little bit of a chance to see it will be great. So I'm just going to quickly talk about a couple other little historical eclipses. But first, I just remembered we're about at the halfway point. So it's time I remind everyone you are listening to York Universe. We're broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. Our amazing observatory crew is right now on YouTube, moving the telescope around and going from the moon out to Jupiter. That's right, it's actually clear weather in Toronto. So we're showing the live images from the 1 meter telescope over on our YouTube channel now. If you're listening to this not live, you can still catch all of those great images as a recording. To find out more about our live shows and, of course, our in-person tours, you can always go to yorku.ca/science/observatory, where all of the free tickets and information are available. Tonight, you're listening to Parisa and Elena, and we're currently discussing lots of eclipses because it is time for more eclipses. Speaking of, I'm going to go ahead and just cover two more fun ones from history um, that happened pretty much this week. So I've actually got two March 7th eclipses. We have a total solar eclipse in 1598. 1598, wow, long time ago. This eclipse had a total solar eclipse. And now we've been talking about solar versus lunar eclipses, and it's very important to note that these are pretty much the opposite of each other. Eclipses on Earth come in two sorts, lunar and solar. The lunar eclipse, of course, occurs when the moon moves into Earth's shadow. So your orientation is sun, then a lot of distance, then the Earth, a lot more distance than the moon. And so you have these very far spread apart things, but the sun is very, very bright. And so it's shining its light onto the earth's casting a shadow, and the moon is traveling into that shadow for the total lunar eclipse. The other way around, that's your solar eclipse. You have sun, and then the moon, and then earth. So the sun hits the moon, and the moon casts its shadow down on earth. The moon is much, much smaller, and so it casts a very tiny little shadow that only hits a little tiny part of Earth. And you have to be standing right underneath that shadow to actually get to see the total solar eclipse, which makes them much, much harder to view, even though they happen just about as often as the lunar eclipses. So 1598, March 7th, totality was visible from the British Isles. And there's this little tiny track that went from Cornwall in the southwest to Aberdeen in the north of Scotland. It was actually observed from Germany by the famous astronomer Tycho Brahe. If you've ever heard of Tycho Brahe, he's famous for a lot of reasons, but he had basically the best telescopes of his time. The James Webb Space Telescope, if you will, of 1598. Um, and it's worth noting that, of course, this telescope that he had was very, very different from telescopes we have now because it did not have the mirrors and reflective capability that we see, for example, on our 1 meter telescope. So apologies to Tycho Brahe, but we can actually get much better views at the moment. And another fun thing is this March 7th, 1598 eclipse actually got its own name when it went over Scotland, and it became known as Black Saturday. This particular eclipse, we actually have pretty good records for, as well as good calculations. And it was a very fast eclipse, almost blink and you'll miss it. It only had totality where it actually turned the sky dark for 1 minute and 29 seconds. Very, very quick. The nickname is very memorable, Black Saturday. So this was a fun one that got viewed by many, many folks throughout Europe. And because, of course, these eclipses do tend to line up in certain ways, we have the same exact day, March 7th, occurring again with a total eclipse in 1970. That's right, March 7th, 1970 as well. And this eclipse is also has, of course, great calculations. We know exactly what its eclipse properties were. We know that it lasted 3 minutes and 28 seconds, so much, much more time to view. And we know exactly what parts of North America it went through. This one was in the 1970s, so people had cameras and we had news stations and people were traveling to try to get to it. This total solar eclipse, this is when, of course, you have the moon blocking out the light from the sun, just like what happened in North America last year, 2024, in April. Everyone got very excited, driving as fast as we can to find if we can get into totality. But the greatest eclipse actually occurred over Mexico at 11:38 a.m. Central Standard Time. And in the US, there were a few places that got a little bit of eclipse path of about 3 minutes. Um, and Florida, I believe, was one of the places that got hit, and the very tip, I think, of Maine as well. So totality went through the US from Mexico and then just into eastern Canada and northern, let me see if I can pronounce this correctly, Miquelon Langlade, which is in the French overseas directly collectivity, sort of St. Pierre and Miquelon. So it did have a partial eclipse associated with it as well. So if you're not in the path of totality and you have a safe solar viewing mechanism, you can get a partial solar eclipse. So lots of places in Hawaii and North America and Canada all got to see this partial eclipse. And scientifically, this eclipse was also used to do some experiments. We actually saw a radio transmission get slowed down from North Carolina to Washington, D.C. And it has a little bit of history because this solar eclipse in 1970, was the very first color broadcast of a total eclipse. So people had taken pictures before, but no one had actually managed to get an actual color broadcast before this time. There were lots of people out observing it. They had lots of astronomers and, of course, scientists going out to Mexico, where the greatest sort of time for totality was happening. And one great thing that you can do if you have a total solar eclipse is to analyze the sun's corona or outer atmosphere that normally you can't see because the sun is so incredibly bright. It stops us from looking at it. But if the sun's light is blocked, you can actually look at the corona of the sun and analyze things like the magnetic structure and all kinds of great things. And of course, what you were saying before, Parisa, there were people actually looking at torsion pendulums and gravimeters and did get some what they're calling anomalous changes, very, very, very small magnitude anomalous changes. So part of the debate, and the torsion pendulum in particular uh, measured something called the Saxel effect. So what do scientists do when there are eclipses? run out and do all the measurements that it's going to let you make. Very, very fun stuff. So that's our little eclipses in history. Now, of course, we have some eclipse and moon news as well. Now, before we get to moon news, I do have just a couple little reminders. First and foremost, the Allan Carswell Observatory would like to just remind everyone that the astronomer in residence applications are open. So if you know an astronomer who loves beautiful dark sky preserves and doesn't mind camping in a very nice apartment with running water, um, we have an astronomer in residence program where we go out to Killarney Park in Ontario. And if you are camping out there, please come by the telescopes and visit our shows. If you want to apply, applications are now open, but they do close at the end of April. So make sure to get your application in if you're going to apply this year. And of course, the really big news is we do have a lunar eclipse happening on March 13th, 2025, this year. So all of the history of eclipses and moons aside, what we can look for in Ontario and in the Eastern time zone is on March 13th, as we approach midnight, the moon will slowly move into Earth's shadow. And it's going to start by going into Earth's penumbra. And of course, that is the outer part of Earth's shadow. It's the less shaded shadow, if that makes sense. So there's two parts to Earth's shadow. There's sort of an outer, slightly shaded region, and then there's an inner region where the full shadow is cast. The penumbra is the outer region, and the umbra is the inner region. So as the moon goes into Earth's penumbra, it looks like just like a little tiny bit of a shadow or just a smidge of cloud is sort of going over the moon. It's very, very hard to notice, and most people don't see much of an effect for the moon going into the penumbra. Where you really see the effect is when the moon enters the umbra, the darkest part of Earth's shadow. And so this is the sun on the daylight side of Earth, the moon on the nighttime side of Earth, and that sunlight is being blocked by Earth. And so the moon moves into Earth's umbra and it looks like it's getting a bite taken out of it. And then when it finally enters fully into the shadow, it appears that beautiful dark red color that we associate with the total lunar eclipse, sometimes called the blood moon. And of course, it's not really anything to do with vampires or werewolves, don't worry. It's really just because of Earth's atmosphere taking that red light. So Earth is, of course, casting a shadow, and our atmosphere can bend light a little bit. So if you are ever looking towards the sunset and you notice it all gets very red, it's because it's traveled through quite a lot of atmosphere. So if Earth is blocking the light for the moon, well, our atmosphere sends that red light through, and that red light is what reaches the moon. And of course, that's what reflects back to us. So it looks red. It's pretty cool. And that is all happening as you go from March 13th to March 14th. So if you want to catch the red total eclipse in Toronto, you need to stay up until 2:26 a.m. The maximum eclipse is at 3 a.m. and the total red moon will end around 3:31 a.m. You do have about an hour to view it. If you are on the West Coast, of course, you can start all this 3 hours earlier and end by midnight. But on the East Coast in Eastern Time for Ontario, you'll want to start around, well, maybe midnight or 1 a.m. and stop around 3 or 3:30 a.m. Conversely, what I recommend to some people, if you can't stay up all night, just set your alarm for about 3 o'clock in the morning, run out and have a look. It should be beautiful and red, and you can get great pictures even with a cell phone. But you don't even have to take pictures, just go outside and enjoy it. It is going to be very, very visible, even from cities, even if you don't have binoculars. It's one of the most visible and easiest to share astronomical events. So I very much encourage everyone to go outside and take a look on the 13th or 14th, depending on where you are. So just watch out with that day. Make sure to set your alarms correctly. Um, so that's the big news of this week. And of course, it's not the only lunar news of this week. We also have some really interesting things happening out on the moon. Paritha, do you want to talk about this Firefly Blue Ghost mission?
Yeah, of course. This past week has been very exciting. One for lunar exploration, and as two private companies successfully landed spacecraft on the moon. And then the idea of, non-governmental moon landing might have seemed very kind of science fiction a few decades ago, but today it's happening. And Firefly Aerospace Blue Ghost Mission 1 and Intuitive Machine Athena both reached the lunar surface last week. But as with all space mission, sometimes they come with some challenges, and these landings were no expectation as well. So first, we've got on March 2nd, 2025, a couple days ago, the Firefly Aerospace achieved landing its Blue Ghost spacecraft in Mare Crisium. That's just like a vast lunar reason that we just talked about it. It's kind of like a happy face. And this mission, part of NASA's commercial lunar payload service, they call it CLPS program, and carried 10 scientific instruments, including tools to study lunar soil and measure some subsurface temperature of the moon. But and these lander is expected to operate for about 14 Earth days before a lunar night sets in, and making the most of its time on the surface. And this basically kind of it was very interesting because that landing shows the growth of role of some private companies in lunar exploration that we see more and more, and I think that's kind of exciting. um but then the second one, also, we got another one called Intuitive Machine Athena Mission that just 4 days ago on March 6th, 2025, Intuitive Machine lander touched down near the moon's south pole. And however, post landing analysis suggests that the spacecraft may have ended up in an unexpected orientation, potentially affecting its ability to generate power, which basically means it's having some difficulties to recharge its battery. And so that might face some complication in its objectives. But Asana, despite all these hurdles, have been able to transmit some data back to Earth, and mission engineers are working to set this situation apparently to maximize its operational time. But since like the battery got some problem, so they just I think the guess is just like it can just transmit some data until it's on, but I don't know what's gonna happen after. But this landing follows Intuitive Machine previous mission with Odysseus lander, and that also had some technical difficulties as well. So this is also some challenges when private companies collaborate with NASA and send some exploration. But I think that's still a very good step that we see some private sectors get involved. And yeah, so I think that's very cool that NASA had this how do you call it, like a CLPS program that it designed to accelerate some lunar science and technology development with the help of some private sectors. And yeah, so with upcoming crewed Artemis mission and more commercial lunar ventures on the horizon, I think these landing service are very important and very exciting. So yeah, so a lot of things going went on last week for on Moon.
Yeah, it's a busy place at the moment, the moon. And of course, the southern pole is where they have been mapping water ice in those craters that never see the sunlight. And it's interesting to see how many missions to the moon have been really, really increasing lately because, of course, after we sort of stopped going to the moon, in with the Apollo program stopped and they stopped sending crewed missions, and then they kind of stopped sending even flybys. And by the 1970s, we were only getting just a few missions to the moon going from Russia as flybys or orbiters. And then in 1980, actually nobody went to the moon at all. At least nobody that published anything. No flyby, no orbiter for all of 1980, nothing. Until 1990, we finally had some flybys from Japan, actually. But still very, very few missions to the moon in the 90s. And now we're seeing, okay, I can't even remember how many missions have gone in the last couple of years. We've had missions from China, we've had India Space Agency go, we've had this recent mission that you were just talking about. And so getting a lot more people interested in trying out different kinds of lunar landers and different kinds of orbiters means that we have a better chance of getting technology to the point where it's not maybe quite so hard to get there because it is still a real challenge to get to the moon without crashing. It's an achievement for anyone who manages it. So the fact that they're able to send a few pictures back, even if it didn't quite work out, is still, as you say, a qualified success. But of course, the moon is something that probably none of us will be able to get private missions to anytime soon. So watching the lunar eclipse might be one way that we can kind of participate a little bit. And one of the things I always like to think about is not only, exploring the moon, but also looking back in history and letting the lunar eclipses and the history of lunar eclipses help us with our own human history, because we've had so many different kinds of events in human history that are just not well documented. One of the great things about the moon is it's been up there for billions of years. And if you ask a human what happened, 5,000 years ago or 10,000 years ago, it gets very, very hard. We don't have good writings or records, even just the last 2,000 years. So it's worth noting that as you go back in time, it's almost as interesting as going forward in time. So this is the year 2025, or approximately 2025 CE, or Common Era. If you want to go back in time with lunar eclipses, you actually have to include CE and BCE. So the way that our current calendar works is very weird. What we do is we go 2025, 2024, 2023, all the way to zero. And then zero doesn't actually count. It's actually zero and one are the same. And then you go back the other way. So 2025 plus one years ago would be one BCE, if I'm saying that correctly. I hope I am. So if you want to go back 1,000 years ago, you're in 1025. But if you want to go back 3,000 years ago, you're in 1025 BCE. So it goes across the zero line. And then your numbers get larger and larger as you go farther back in time. So If you have something that was, let's see, this is 2025, what's an easy number to do? Um, 12,500 years ago would be 10,000 BCE. So the 2025 comes on this side of the line, if that makes sense. And all of those years, we can calculate lunar and solar eclipses for. They're one of the great ways that we can date history and historical items. So I would like to just give a little shout out, and we were talking about this before, Parisa, some of the amazing calendars and date systems as you go back in time. It gets harder and harder to retrieve um, good written records. Ancient Mesopotamia would be some of the oldest ones, which are around 3,500 BCE. So that's 3,500 plus 2025, 2025 years ago. So 5,000-ish, right? We'll make some rounding errors. So if you want to go back to ancient Mesopotamia, very few records from that time of, 6,000 years ago exist. But some of them do include eclipses. And as you go across that zero line to just, 2,000 years ago or so, we start to get better and better records. And one of the very favorite ones I think that a lot of us in astronomy like to use are some of the old celestial calendars and calculations out of Arabian astronomy, because Arabic scholars have sorry have helped keep alive some of the Greek knowledge and preserved Greek copies of books, as well as adding tremendous amounts of other knowledge. Um, so Arabic astronomers made a lot of improvements onto the Ptolemaic model and put in things like more accurate stellar predictions, but also the first sizes of the solar system and lunar eclipses. And this is where I get into, as I say, one of our favorites is Al Biruni. And am I saying that right, Parisa?
Yeah. He was based actually Persian and like from the ancient Iran, and like the true name is like Abu Rayhan Biruni. So I think yeah, Biruni is how I think they pronounce it's his name.
Excellent. Yeah, and of course he has produced some wonderful, wonderful works in science and in astronomy, and as you pointed out earlier, poetry as well. But anyone who wants to see one of probably the best and clearest examples of the phases of the moon and with respect to the position of the sun, showing you exactly how eclipses work, it's actually an illustration from one of his astronomical works. And so if you search for Al-Biruni, phases of the moon, a drawing will appear that's in black and red and shows you exactly how the phases of the moon line up. And even if you can't read the Persian, it's so astonishingly clear that I think it's still used in, well, it's still used in my early astronomy classes, but it's still used in basic astronomy classes all over the world. It has really aged incredibly, incredibly well. And this was done in the year 973, or about 200 years after this sort of really picked up a lot of the sort of astronomy boom in that area. And really, really excellent, excellent stuff. So I always like to put in a little bit of history just at the end of the show. Were you ever able to read any of that, Parisa?
Yeah, it's a little bit hard for me because it's like an old Persian, but what I can read is just like the position of the sun and moon and earth, which is written on it, and also I think in a poet in a yeah, in a poetry down below the sketch, He basically tried to explain what's happening, but in a poetry form, which is kind of cool. But it's a little bit hard for me to understand fully.
Well, that's an excellent one for the translators, and it is one of those areas where there are still so many documents untranslated. It's a real treasure trove of astronomy history. All right, I think we have to end off there. So whether you're interested in eclipses past, present, or future, or just exploring the moon a little bit, um, keep an eye out for March 13th or March 14th, very, very early in the morning, for that total lunar eclipse coming to pretty much all of Canada and almost all of North America very, very soon. It's exciting times. Everyone, thank you for joining us. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Parisa Nozari and myself, Dr. Elena Hyde. You can always connect with us on Instagram at the handle at York Observatory, PixelFed at Allan Carswell Observatory, and Facebook at Allan Carswell Obs. And of course, check out that same website for show notes, content, updates, and more at yorku.ca/science/observatory. Thanks for tuning in, everyone. Clear skies and have a good night.